Okay, so what we were talking about is some joins and some other types of functions here. And I remember joins were actually quite exciting because joins were taking the information from two different tables and putting them together. And so you're kind of combining information. And so your join is if you may have information in two different tables here, and so you may need to take that information out and do something with it. So you do something like a join to kind of zipper your slides or your table contents together. And so that's really what these are. And so we discussed the left, right, and full joins. We talked about some Venn diagrams that describe how the information is actually coming together. Underneath each of these Venn diagrams, you'll notice that there is some code that you can use to kind of lead your thinking in how these joins actually work. I think that we spent a lot of time using the left join here, which you'll see is in the upper left. And I think that if you think in terms of left joins and right joins, if you just always treat your right joins, you rewrite them as left joins, then you only have to remember the code for just one type of join here. But you have both of these different joins here. The right join is on the right and the left is on the left. And you're just taking the information out of the left for the left join. You're taking the information from the table A, and you're using that as your, what I call like your leading table. And you're finding that associated data in the B table, and you're joining tables together where the table A has data. I know that sounds kind of like making things even more confusing, but actually though, it's not as confusing as it may seem. And so if you think in terms of, you're using your, let's go back to this table here. If you're thinking in terms of like your left and your right tables, so I'm looking at my X table and my Y table. My X table, my left join is my leading table. And what it's doing is I'm looking for my keys, which are keys 1, 2, and 3. I'm looking for those keys in the Y table. And where those same keys exist in the Y table, that's where the pairing can be found. So in this case, you'll see that when I left join the X table and the Y table, X has keys 1, 2, and 3, and Y has keys 1, 2, and 4. Well, the thing is, though, that you'll see that in the output, the table is 1, 2, and 3, keys 1, 2, and 3, and the Y table has no key for, or no data for key 3, and so therefore you have this hole in your table. It still stitches it together so that the information is led by, or the actual join is led by the X table. Now on the on the right table here, you'll see on the right-hand side there's the Y table. Now this time the Y table is being used as our join, so that means that the Y is being used as the leading table, and anytime those keys are present in the X table, then those keys are combined such that we have the information from the X table there too. So that is why, for instance, when you look at the table on the output table, we have keys 1, 2, and 4. Well, those keys 1, 2, and 4, looking at the output table, they came from the Y table's keys. And you'll notice that the X table for key equals 4 has no data in the output. And that's because there is no key for the X table for key number 4. There's nothing there to combine. And so one of the big points that I made is that when you stitch together tables like this, and you might do this if you have like two different databases that you're trying to use, or you're trying to get data from different websites, you're trying to put together data from two different sources. You may get holes in your data, and that becomes kind of a problem, because then you find that if your table schema has been written in a way such that there's no if you have a not null constraint, that means that whole record could be thrown away, or you may not. If you're trying to populate a table with this joined information, that whole record could be thrown away if you have constraints that permit or that prohibit the partial tuples to be populated into those tables. And I think we'll see that going forward here. But just remember, though, for right now, the joins, though, you don't always get perfect information when you join two tables together, because things can be missing. I guess this is the same way if you talk to two different friends of yours about what movies they enjoyed and why they enjoyed those movies. Each person's going to be talking about the main features of that movie. Oh, I really enjoyed this scene or that scene. But then each person has their own specific areas of interest in that film, and so you might get information from your first friend about this movie where something over here happens, or this scene, but then your other friend is never going to mention that scene, and in fact mentions other scenes. And so you have this different, you have like kind of it's like a different story from each person. And maybe you can use that in your analysis. Maybe you can somehow put that, maybe you can stitch together these two tables, the partial information, stitch it together in some way so that you can get some kind of better coverage of what you're trying to study. But anyway, we'll move on here. So we have the cross and the inner joins. The cross joins were kind of like your cross products here. This was just a cross join. I invite you to look at this code where you're creating decks of cards from the suites and the ranks, which is kind of interesting. And then there's this other piece of code here from the inner that's demonstrating how to use inner joins, which is this fruitjoin.txt file that is actually quite interesting. In fact, if you look at this thing, let's go ahead and put this into my well, actually maybe I think I actually have this code already in our thing. So let me just go ahead and find it. Sorry, it's me again. So if you go to your class docs repository here, let's see, all CS312, class docs, lessons, and then we're at 04. Then we have to go into sandbox. Our sandbox here. Then you'll find that inside source, you actually have this file here called fruitjoin, and that's this code that you'll see up here. And so you can always run this. But the only thing about this fruitjoin is that you may have to run it. I have to run this in an editor first of all, and actually copy and paste this code so that it doesn't create any problems. Maybe I'll go ahead and just grab everything. Shoot, I'll get everything there. I need to get this a bit bigger. Hopefully you can see all this as I squash this into the screen a bit more here. I guess that's good enough for now. I'll just go ahead and select everything. And then if I get out of this, by the way, this is the software I'm using right now. It's called Vim. It's a line, or it's like a bash editor. It's like you can edit your codes line by line if you want. It's not as exciting as Atom, but it is quite a good editor. Then once I have this, then I can go into SQLite, and it's here that I can actually paste this code. And hopefully that will work just as well. Whoops. Okay, so if I type in tables, hopefully I get my tables A and table B. And so I can look at my previous, here we are, this is my previous query. And you'll see that, let me just show you what's in the tables. Table A, table B. So what we have here is the lemons are yellow, apples are red, and then we have grapes are purple. And then that's from table A. Table B says that lemons are yellow, apples are red, and oranges are orange. And so what we're doing with this particular query here is we are combining these two tables here, provided that the color is the same. So it says that it's going to first of all look at this table and say, okay, well I have yellow here, and so that's yellow is in this table, in table A, and yellow is also in table B. Red is in table A as it is in table B, but purple is in table A and not in table B. And orange is in table B, but not in table A. And so that's how this query comes together. I hope you spend some time looking at these queries and kind of getting used to how they work, because they could be actually quite handy later on as you're working with some of your own queries. You might need to pull information out of two tables here such that something is matching. So there's that, and so we have this information, which is actually kind of cool. The other one was the Cartesian cross, or the Cartesian join, which is kind of like your cross join, where you're just taking x times y for tables x and table y. And I think I have, here we go. So we have some data you can look at, and it just puts together one from table A, and then it lists 1, 2, 3, 4, 5, 6, 7, 8, 9 from table B, and then it lists table 2, and then lists 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9. For each of these numbers here match with are made into pairs with each of these numbers down here, and so that's your Cartesian. So I invite you to try that. But mathematically, though, if you want to think about the math of all this, this is your graph theoretic table to describe a click of what's going on. You don't need to know what a click is, but it basically means that every single piece of information is connected to every other piece of information. And so that's what these joins will do. Every piece of information in each table is connected to every other piece of information. One thing about this is that this goes back to the relationships. And that is that when you design your database, again, your relationship is going to make this table possible, or this join possible. Everything that we've done up to now has been reliant on the relationship. And all the queries that we write here, everything that we're doing, we have to make sure that the relationships are good relationships, logical relationships, since they're easy to use, but also that they do work to bring our data together. Because after all, if you have a relationship that doesn't work, or it's not very good, then it's going to be, it'll be difficult to write queries such that you can actually get information that you're looking for. Okay, then we have the inner joins and some other, so the inner joins, I think we just discussed them a little bit, but this is like a Venn diagram of the joins here. And so, for instance, in this case here, the left join is the blue, and this is just another way of showing them. But here we have the blue and the green, and so here with the left join, you're using the blue table to lead the join from the yellow table, and really you're looking for the stuff that's in common with both of these tables here, such that everything in this case is green. On the right, if you're doing a right join using Venn table or Venn diagrams, then you're using the yellow table to do your join. And so you're finding all the common information from yellow in blue, so you're again looking for yellow and green. So hopefully that makes things easy. Anyway, but what we were spending some time on, let me just move forward here to the actual where we are now. I mean, those are just important pieces, but we moved into this new database, the campus database, where we were, I think we left off, where did we leave off? Around here someplace, where we're looking at the database contents from instructor and course, and we are using a different kind of join here, where in this case we're using the union. So let me just go back and see if I can find that table and get back to where we were before. Remember that if you're in SQLite here, you want to type in .exit to get out. Don't just exit out your window, because that's going to crash your SQLite. Remember, SQLite is a program that's running inside your terminal. And so if you just close the terminal without closing the program, then you're actually crashing the program. And sometimes programs might complain, or you might lose data. Now remember, let me just make this point again here. But I'm using this file here, this builder file, to build my campus database. Now, please do pay attention to this thing here, because over the weekend I received several pieces of Slack messages asking how to build a database. This is week 5. You should know how to do this. There's no excuse for not knowing how to build a database. You do not copy this code, this cat code here. Do not copy this inside your SQLite. So for instance, what I'm talking about is you want to be inside the bash. This is the bash right here. This is your bash terminal. If you type in this code right here, if you type in SQLite 3 here, and then you paste this in like that, it's not going to work. In fact, you'll just get this, and you'll be thinking, how do I get out of this? You push your semicolon, sorry. There, you push your semicolon and you get out. So you do not build your database inside here. That's just wrong. So you want to get out of this thing here and then get back to your bash. This is where your cat command actually does work. So what you're going to do is you're going to be typing cat followed by the builder. If you can type this command in here and read the file in your bash, not SQL3, but if you can type this in here, then that means you can go ahead and pipe this into your SQLite 3 database here. So I'm just going to make a directory. I'll just call it mydb, or I'll make a database mydb, something. I'll erase this later because I've already done this. But otherwise, you can see that at the bottom of every build file, in fact, I'll use the files that I use here. At the bottom of every build file that I give you, you have the actual command that you're to type. And so please do spend some time learning how to use these. I mean, this is week 5. And so once you type in this command here in your bash, where you should see something like this, where you're actually typing in commands, then it should work. You get some complaints here, but that's just because some of the foreign keys are being tripped. They don't like what they're seeing, but that's okay. That was part of the lesson that we had when we did foreign keys. So I just left it there. But now you've just built your database, which is this file right here. And so you need to actually run this database. And so another message that I received over the weekend from several people is that when they're trying to get into their database, they type in SQLite3 and they type in tables, and nothing comes up. Select all from courses, of course, and nothing comes. There's no table. What's going wrong? Did I do something wrong? No. What happened is you just didn't load your database. Because this is just the program by itself, but you have to tell it what database you're going to be loading here. And so your database is this campus DB. So you have to type in your file or your database manager, your SQLite3, followed by the database itself. Otherwise, it's not going to come up, and you won't find anything. So please, please, please do remember those commands because they will serve you well. It's like I know that some people were. I got a mail from over the weekend saying that somebody was pulling their hair out. I hope that you didn't pull out your hair. But it's just as simple as that, though. You have your build command, and then you have this. But please do remember these things. I'm going to write them down and play with them and make sure that you know how they work. And then when you type in tables here, you should find all your tables are back. All right, so don't despair. I am here, but please remember these commands. Now, getting back to my slides, let's see what we have here. So we're talking about this union business, and the union is actually quite interesting because what you're doing is you are looking to see how you can combine the contents of the instructor in this particular query with the course. I'm combining the department name of instructor of the instructor table with the department name of course table. And so if I go back here and just dump these into my thing here, oops, you know what? I need to put some spaces in here. There we go. So what this has done now is it's okay. Go to the instructor table. Actually, not. I need to go to select here, but I think I'll do department name from instructor. So it says go to the instructor table here and list all the department name information. Then go to the course table here and list all the information from the course. Then this command here, this union, it says put everything together. But you'll notice that it doesn't give you repetition because the SQLite thinks, well, you already know that Comp Bio and Comp Sci and English, French, and Latin, or math, are parts of these tables. You probably don't need to know how many times they occur. If you do, that's another query. But this is your distinct view of how many of these, how many different department names there are. Cool. And then we have the intersect, which does the same thing here, where you're just saying, okay, well, give me everything. Put it all, just run it all together and see what it looks like here. So if I go back to this, hopefully I can just go ahead and put that in. I have to put a space between here and here. Okay, so this is saying what's the common department name between instructor and course. And so it tells me that Comp Sci is the only department name which can be found in both tables. That's what your intersect means. So your union is adding everything together, just like combine everything. It's like your addition function. And your intersect is saying find the unique stuff that exists between both, that's common to both tables. In other words, I guess it's your subtract. That makes any sense here, but it's like you're finding the stuff that's common to both tables. That's what they mean by the intersect. Excuse me. So there is that. And so I think that these are actually quite useful commands here. But the thing is, though, that I like these commands because union and intersect, this is just one line of code. I mean, if I had this data in my own database and I wanted to do the same thing, if I had this in a spreadsheet and I wanted to have the same kind of function, I could do that, but it's like there's a bunch of code that I would have to write. Whereas for here, I'm amazed that it's just one line of code and it does all this heavy lifting for me, which is actually kind of nice. So if you, seriously, try this. Try writing something similar like this in Java or C or Python, and it might take you, I don't know, 4 or 5 lines of code, whereas here it's really just one line, which is kind of cool. Anyway, that's just me being me. Then we're looking at we have the sets or the except. I think the except operator compares the results of, let's read this here, the results of sets from 2 queries and then returns the distinct rows from the left query. They're not in the output by the right. So if I go ahead and just, well, maybe I'll just run this and see what it does, and then that'll maybe help us. But again, it works a little bit like the intersect. where we're looking at the stuff in one, which is found in the other. So let me just go ahead and run this here. Select all from, actually, I don't want all, I want department name. Department name from instructor. And then I do the same thing from course. So when I run this command here, it says comp bio and math. And so what it's doing is it says, okay, well, here's math in instructor. Math is not in course. There's no math down here, but math is an instructor. And let's see, comp bio should also be up here, but it's an instructor, but it's not found in course. And so this is kind of like your union function again, but it's more of a join in some cases here. You're joining things together such that you're finding, you're looking for the information which is found up here in the first table, which is not found down here. And so that's why math and comp bio show up, because they're here, but they're not here. And so it's like your intersection with subtraction. Yeah, I think maybe I'll move on. The next thing I wanted to talk about, though, was this as clause, which I know sounds like some kind of ridiculous insult. I hate to use this as clause here, but the as clause is used if you're working with strings. That's at least how I tend to use it. But it has other things. It's like you're getting to the realm of working with wildcards. So let me just go ahead and try something. I guess we don't have any. Well, let's try this one here. Select distinct name from instructor where, let's go ahead and put this in here. But you're, oh, no, okay, let's read this here. Okay, so what this is saying here is that this, let's maybe run this one here, this might be easier. But it says, for all instructors in the university who have taught some class or some course here, find their names and the course ID of their taught courses. And so you're able to kind of reduce the search space just a little bit here and make it more, so you can find some specific particulars of your specific particulars. You can find some information that you're looking for in your tables. Let me go ahead and put this all on one line here. Let me go to my editor and work with this. I'll put this here, make sure that this is all going to be on one line here, and I just go ahead and show you what it looks like, and you'll see yourselves. Course ID, there's a space there, there's a space here, teaches, T-where, put this right here, I'm going to copy that, paste that in, oops, paste that in here. There we go. And if I go there and I'll just drop this in there. Oh, instructors as, you know what, let's put the space here. Okay, so what we have here is we're looking at the different types of teachers who are available, or we're looking at the teachers Miller from the instructor table, and from the, we're looking at the Miller table, and we're looking to see what Miller teaches, what Johnson teaches, what Charleston teaches, and what Thompson teaches. And so this, let me go back to the slides here. Maybe there's a better way of saying this. The reason why I'm getting confused here is because I should probably talk about these lines here first of all. So look at the color here. So this part right here, this instructor as I here, I name here. What we're doing here is we're putting together this. We're using this. This is a variable here, saying that this variable or this attribute name is coming from this table I here, and then the blue stuff over here teaches as T. So what we're doing here is we're saying that we're making another kind of a table here, another piece of information where you're getting the course ID, where I ID is equal to T ID, and so you're combining the information together such that you're kind of creating two different tables again. Let's go back to the slides here. So in these slides here, you're looking at the select name from instructor, where a name like percent ILLE percent, or not percent, percent here. But this is what your structure is going to look like of the text. And so if I go ahead and copy this, and then I go back to transition to this, and I paste this in there, Miller. Okay. So if I wanted to go after, like, that's Miller, and you can see that Miller's name here, Miller is ILLE. And so in this particular in my regular expression here, I'm looking for ILLE. Now, this percentage sign here says the letter in front of it could be anything. And this percentage right here means the letter behind it could be anything. And so I could go through and actually change this around. And so let's go after Johnson here and see whether we can find something that's similar to that. So again, what I'm going to do is each character has to be kind of spelled out by this wildcard, which is this percentage sign. So Johnson, I'll say JOHNSON. Let's just say that that's what my thing's going to look like. Johnson, I have to have this. If I don't know the first character, I could use this. Percentage sign here to kind of be a wildcard for J. Now, if I put another percentage sign at the end, is it going to still work? It still works too. And so it says, give me anything where these letters actually do come together, and then I have this, and then I could have something in the end, and I could have something up here. But otherwise, my actual search I'm looking for is specifically this. So let's try another one here. Let's look for Nelson. Let's see what's going on here with Nelson. So let's say where name is like, how about, I don't know whether it's, if I put this son here, does that do anything here? There we are. Everyone's name who ends with son, I can use this wildcard here and say, okay, give me all the names for which they begin with something, whatever it may be, but they actually do have the word son inside them. And so here we have Johnson, Charleston, Thompson, Jackson, Watson, and Nelson. So you're able to actually do some quite sophisticated types of queries here with these wildcards. Going back to the slides here, another one that's kind of interesting is you have this. Let's say that I don't know what the name is, but I do know that there's just a couple of L's that are together, and there's some other stuff. But I'm looking for everyone's name who has like L's that are parallel in the middle here, some parallel L's. So I can go ahead and put this other one in here, name like LL. If I type it in as it is right here, it's not going to work. And so what I have to do, it's not going to work. So I have to put in, like, for instance, I'm going after William. So I know that William's name has something is there. There's WI, but let's say I don't know what they are. Let's say that there's two characters in front, and then there's three characters afterwards. If I push enter, then I get William. And so what this is now doing is this is saying, well, I'm looking to find a specific name where the third and the fourth characters are L's, are both L's. Anyway, this may help you if you're looking for names. If you're doing like a name lookup, or you're looking up some kind of textual information, it may help you in that sense here. Okay, well, I'm going to move on to the next thing here. These are actually much more complicated things here. I'm not going to run these, but these are actually much more complicated regular expressions that you can use. You can find a special pattern if actually your strings. If you know what regular expressions are, then this slide is suggesting that you can just type in those regular expressions in this kind of order here, and it should work just fine. You should be able to find the text you're looking for using regular expressions. I guess the last piece that I really want to go over here, we're kind of running to the end. But this is like how do you order your information? And I think that the best way of doing this is just to run this in here. I'll just run this query there. If I go back to my slides, I go here, and I run this. What this is doing now is I'm saying, okay, give me the name and the salary from the instructor table and order by the salary. And so by that, I'm sorting things. So you can see that there's 7,000, 9,000, 97,000, 97,000, 98,000. And so it's kind of giving me everything in this ascending order as this goes down. And so you have this, that's what order does. It helps you to sort things. If I remove this order by salary, then it just gives me all this information as it shows up in the table, but it doesn't necessarily mean that it's being ordered. I could order this by salary. Let's see, could I order this by name, perhaps? There we go. So ordering this by name, I have Charleston's up front, and I have William at the bottom here. And if I remove this, you'll see that Miller's at the front here. And so really, you can order the output of your tables quite conveniently this way. The next thing is called having. Having, you can put together some extra conditions in your conditional statements here. You can actually add some more sophisticated conditions. So I can group things as I just did here, but I can actually create more. If I have multiple columns that I want to group things by, I can order the first column. I can order my data by the name and then also by salary, and I can you can sort things in multiple ways. But what I wanted to show you about is I want to show you this thing here. Here's a quote, or here's a thing, a query that says give the number of names and the names of all members of departments who make less than $1,000 in their 100,000 in their salary. So if I go here, let me go ahead and just dump this and that. Oh, where is it? Oh, it's right here. Space. Okay, so what this has done here is it's going through and it's figuring out how many names are there in the departments who, in comp sci or comp bio or math, who make less than $100,000. And so if I go ahead and just give you a search of what's in this instructor table here, okay, you'll see that there are some people from comp bio who are making less than $100,000. And so those people be right here. That's one of these people here. And so this is creating mini groups of all these departments here. So I'm saying group by department name here. So so go through my list, put all the names according to their department name. And then I want you to further sort that information such that the names that you actually give me are those people who have salaries less than $100,000, which is actually kind of cool. I can change this around. I can say, for instance, salaries which are greater than, let's just say, 98,000. So you can see that math is greater than 98,000. Why is that? So who's math in this case? This person right here, William. William seems to be making 99,000 as a salary, and he's from math, and it seems that nobody else is making that kind of money well, this is, I guess that's it. Oh, that's it. It's and Mauler. So these are the two guys in math who are making this kind of money. Less or greater than 98,000. They make 99,000. Very cool. Anyway, there's another example you can look at here, for instance, where give me all the names of the people who are in the table here for departments that begin with C. And so if I go to just copy this in here, I'll go and paste that in there. And let's see, by department name. So this is now going through and it's saying, okay, let's order these department names that begin with C and then give me the average salaries in each of those departments. And so, for instance, math and what else is there? I guess French or anything else. I guess math. Math is ignored here because math doesn't begin with C. But comp sci and comp bio does begin with C, and so therefore we're going through this table. We're finding all the comp sci people, all the comp bio people, and then we average their salaries, and that's what this information is right here. And so if you're human resources, you can see how much each department may be making by creating these kinds of constraints. So if I do, like, for instance, like M, I can say, well, just sort everything into all the department names that begin with M, which is basically just math. And so that's where this information is coming from here. All the department names that begin with M, there's only one, and that's math. But otherwise, if I have C here, you can see there's two departments that begin with C. Kind of cool. There are some other ones that you can look at. I kind of wanted to, I don't know if I should do all of them here. I can do this one here. But this is another one you can look at. I'll just do it at the bottom here. This is actually kind of cool. But for instance, if I wanted to find, for instance, all the, find all the departments here, let's see, all the department names and the salaries from people in the instructor table where they make between 97,000 and 100,000. I could use this query here, but this query also groups by the department name. So let's go back here and see what that query looks like. Don't have to run. And so you can see that I'm listing the department name and the salary, which is this information that comes out here, where the salary is between 100,000 and 97,000. Now, how do I do that? I say where the salary is less than 100,000, and you have this and in here, very important, and the salary is greater than 97,000. So that's saying that if you're inside that window, that salary window right there, then I'm interested in listing those departments and those salaries. Now, this final thing here, group by department name, you can see this at the very end here. That scrolls on the front page. But what that means is that you are looking to see, you're going to organize the outputs, I guess, alphabetically by the department name. So if I remove that, let's just remove this and see what happens here, group by. I think the information is still the same, but actually I say, when I group by, you get this, it makes the orders, it makes everything distinct. Otherwise, you get this repetition. You can see before, if I don't have that group by, I see math showing up twice, and I see comp sci showing up twice. And so this group by, as we remember from before, it creates a distinct output, which is actually kind of nice. Are there any questions at all? Are there any questions at all? Let me know if you do have any questions. I think we've actually covered this one before. This is the average. Where do we have this here? Average salary. I think I'll just go through this and just show you what this one looks like here. But this is the reporting the average salaries larger than 97,000. It's very similar to the having clause, but it's just a different way of writing the whole thing here. In fact, maybe I'll just write this here. I'll do the first one first. Going back here, go there, dump this in there. Okay, so this is giving me the department name and the average salary from each of these departments. So it says, okay, give me go through each of these departments, or go through all this information, sort the information by department, and then give me the average salary from each of those departments. Now, going back here, we can use, in fact, this is going to be a nightmare to copy and paste because I know it's going to be crazy. Let me go ahead and edit this in my editor, just to make sure that it doesn't. So I need to move average salary. I don't know why some of these don't show up. Because that's oh, actually, we don't leave that one here. That's actually a variable name. And group by department name. Okay. Now if I go back to my slides, or actually back to my, oops, not that, back to my terminal. There we go. Okay. So it's very similar. What we're doing here is we're looking to see whether the average salary, we're actually creating a new variable. And so this is, I know it seems kind of strange here, but we're calling in a variable which does not exist in the table. Let me just show you here. Schema, and I go to instructor. Okay, so you'll see that in this table, there's no attribute called average salary. We're actually creating that average salary here. So we're using this as right here, saying create this new variable just for this query to store some information. And then that information that we're looking at is the average of the department names where the salary is greater than 97,000. Right, so there's a lot of stuff going on here. But if you just remember, though, that we're actually able now to create our own variables, which actually hold information that then we can use later on when we're reporting that information back. So this is selecting the department name and the average salary, from which we gathered from grouping the departments, looking to see which of those departments were making more than the average salary in the whole list here, and then showing those ones. And so here we have comp bio, where they're actually making more money than, I think, the average. Let's just see here. Select average, oops, 83. Okay, so the average salary in the instructor table is 95,000. So here we're saying, look at the average salary of all the tables, or of all the salaries in the table, and then report back those groups for which the average is above. And that's what this information is here. Okay. And then I think you may have seen between at least some parts of it here. It says that my internet connection is unstable. Hopefully my internet doesn't give out. By the way, if the internet does give out, the building doesn't have perfect internet. I put these slides up, and so you can always see them, and so they're there. But that's really the end of it here. I'm not going to run this one here. I think you can get an idea. But what this is doing is it's looking for the salary information where it's between these two values here. And this one here is I'm looking at the information from the instructor table where the salary between. And so this is between is really a synonym for this, and so it should be exactly the same. Now, what I wanted to talk about though today, right now, is actually two things. Before I get to the practical, I wanted to go into the actual class, planning your time. Hopefully you can see this here. If I go to my class, I go to my databases. If I go to the planning your time link there, I have put down that there's I'm thinking about our exam on week 6 here, which is going to be during lab, which is on the 7th of October. Oh, sorry. Oh, actually, it should be November. This should be October. Yeah, it should be October, not November, but it's October. I'll change that. But what it is, and so for that, during that, so this is next week I'm talking about here. So I'm thinking about exam 1 here. I haven't quite exactly decided how it's going to be, but it's going to be a take-home thing. I mean, obviously it can't be in class. And so be on the lookout here. And so if you have any questions over your database work so far, anything that we've discussed so far, or your labs, please get those questions answered. I mean, you can ask your TLs, you can ask me, but please do get those questions answered. And certainly if you cannot get your software to install, please get your software installed by now. I mean, you'll need this for your exam here. So this is actually a piece that's going to be it's quite an important grade for your course, for your overall course grade. So please do take this seriously. But I'm thinking that it'll be next week during lab time. So really, I guess is that the 7th? Yes, that's right, on the 7th. That's right. So lab's on the 7th. So it'll be that time. So that means there'll be no new lab given next week. But I'll be giving you this exam. But more on that later as we get closer. But in the meantime, though, please do spend some time going through your notes, going through the your build files, learn how to learn the queries that we've gone through, learn how to use them, and understand like the syntax of each of them, just to give you a way of so you're not spending too much time on this exam. Right. Anyway, I'll give you more information as we get closer, but otherwise, that's on the horizon now. Now, the next thing I wanted to... Are there any questions, by the way, over the exam? Just any questions? Claire, do you have any questions? Well, so the question is then, do we have to take this during the lab time? I'm thinking that the lab will be a take-home where you'll have like 24 hours to do it, something like that. And so you'll go. I mean, you don't have to be in lab and do this, but it'll actually be take-home. And the reason for that is because there are some of your colleagues who are they're actually taking this class in a different time zone. And so for them, though, having 24 hours, I mean, their 24 hours would be 24 hours from a convenient time for them. I don't want to make it seem like they're 24 hours from 3 in the morning to 3 in the morning. But they'll have a convenient time to work on this. But I mean, it'll be like a full day to get this whole thing done. And that should be more than sufficient. I mean, typically an exam like this would be given, and you'd have like an hour to get it done. But here you have 23 extra hours to do it. So I think it'll be fun.
I have a question.
Yes.
So normal labs are like 2 hours long. Will this exam take us like 2 hours to complete? Is that the idea?
Well, I don't know how long it'll take you to do, but it's probably going to be something that's very similar to a lab itself, though. So it's going to be basically putting together a database and running some queries. I'll probably end up giving you some data, but you'll have you'll have this huge amount of time, this 24 hours to do everything. And so I don't think that time will be any problem. But if you do need more time, then we can talk about that. And if you find that I don't know what could happen here. If life happens and 24 hours just isn't sufficient, then please let me know and we can discuss. But let me know well before the exam actually starts, like within a day before or so, because otherwise it's you can't just the exam can't go down and then just say, oh wait, by the way, I need more time, because otherwise I have to make preparations for that. But otherwise, though, I'm thinking just a take home. It won't be. It's just a thing you have to do at home. Alrighty. If you have any other questions, if and when, you can always find me on Slack. What I would like you to do, though, is that we do have a practical that I want you to do by next class. If you go to your class docs repository here, you'll see that there is this practical too. One thing I'd like to say, though, is that please do get this thing in on time. I mean, I don't think that anyone, except for maybe 2 people, turned in their practicals on time. this lab for practical 1 here. There are time limits on these things here. And also check your Sakai here. I'm not using Canvas, I'm using Sakai to post grades. And so please check your Sakai to see your grades. And what I'm really asking you to do, though, is to look at your Sakai and see that your repository name is correct, because otherwise I see your repository names and I'm not entirely sure whose repository is whose, because there's no names in these things. So please do check. I think that name, or that the name that I believe your repository to be is in your Sakai postum grade. I guess we call it a grade portal, but it's in there. And so please do look and see make sure that I do have the right repository down for you. Otherwise, your class or your practical 2 is due by next class here at 12. And what you're doing is you're really just going through and you're writing some queries. I give you in the in this file here, practical 2. There's actually a directory that I want you to copy into your practical repository, and then I want you to work in there so that when you push everything out, you're not trying to push your class docs here, but actually you're working in your repository for class. So copy the directory that you find in your class docs sandbox directory into your practicals repository, and then work in there.